Mr. Peter Johnson, agronomist with Real Agriculture, is going to come down to the podium. I still remember one of the last presentations he gave here when he worked for the as the Ontario cereal specialist for years. We had quite an Ontario group there at the time, and there was quite the jokes flying back and forth. A couple of things. He's a resident agronomist with Real Agriculture, where he posts a weekly podcast called Wheat Pete's Word. He's also regular on Agronomy Monday, which I found out about on Monday when I did the agronomist panel and had a lot of good questions on Real Agriculture and Sirius Satellite Radio 147. He spent 30 years with the Ontario as an Ontario cereal specialist. He loves to talk anything agriculture. I see him on Twitter all the time. With that being said, I don't want to cut too much into his time, but he was named one of the top 50 in Canadian agriculture in 2021 and was inducted to the Middlesex County Agricultural Hall of Fame in 2022. Please welcome Peter to the podium.
Thanks very much. You guys should know by now that you never clap for a speaker till they're done and you know if they're worth it or not, right? Yeah. Thank you very much, Tammy. Yeah, I'm done. Yeah. You get up here and do interpretive dance, and it is all good. It's all good. So, oh yeah, there we go. Cool. So thanks very much to Ann Kirk for inviting me here back again, and thanks to everybody who in the MAC organizing committee. It was a great session last night, and this is going to be a whole bunch of fun. And I'm going to really try to get through it and not go over time. That'll be a challenge. I actually should just set my time. Oh, actually, there is one up there. Okay, I got a clock. I'm good to go. But I am, in usual Johnson fashion, going to give you more than you asked me for. Because, I don't know, lodging in cereals is just boring. So that's why everybody left. They already know the answer, right? The answer is you spray a plant growth regulator. Not exactly. But anyway, it is kind of a bit of fun. But I think there's some other cool stuff that we can really look at. 15 seconds of shameless self-promotion. I do work with Real Agriculture. I do a weekly podcast called Wheat Pete's Word. It's kind of a cool thing. You can leave questions. I'll answer them on the next podcast. We get lots of hits. The other thing that we do, of course, Sirius Satellite Radio. We do the Agronomist, as Dennis mentioned, and the schools. So there's, I think right now there's something like 400 wheat schools up on the site. We've been doing the wheat school since 2011, I think, something like that. Canola schools in the same game. And just lots of good stuff there. So if you're looking for stuff, I think we're doing a decent job. Okay, let's go. What is it? What are the most dangerous words in agriculture? We've always done it this way. Exactly. We have always done it this way. And man, so I get to talk once in a while to the students at the University of Guelph. And every time I show this slide, they just say, yeah, dang, could you just tell Grandpa to give it up? Or could you talk to my dad and let me have a little bit different take on things? And so I like this because I really want you to open your mind. And one of the worst things that you can think is that you know the answer, because most of the time that just shuts you down from looking at other alternatives. So I want to start there. We're talking about lodging. I really do think that truck is pretty well lodged. It's going to take something to get that out. And last but not least, I'm going to just talk briefly about this new program that we have in Ontario. It's called the YEN. It's the Yield Enhancement Network. It started in the UK 10 years ago, 11 years ago, I guess now, and it really turns research a bit on its ear. And I was awesome to hear Mario talk about going to farmers' fields to do research, because what the YEN does is it really says, like, we do research, small plot research on the research farms, and they don't always represent what happens in farmers' fields. Because you got to do that research on the most level, flat piece, most uniform piece of ground. You baby it. Not many farmers baby their fields the way that a research location does. So rather, what they found in the UK, because they were doing the same thing, was that they would come up with recommendations, the farmers would take them to the field, and often they wouldn't work, or they wouldn't work the same way. And so the researchers said, okay, we got to do this differently. So now the farmers do the best job they can. They sign up for this program. And when they're in the program, the researchers go out and say, what are they doing that's working? And what are they doing that's not working? And so from a farmer perspective, you get a group of farmers that interact with each other. But the really cool thing is that we calculate yield potential. It's not a yield contest per se, although there's prizes for highest yield, but you calculate yield potential. So this is the Ontario data from 2021. We haven't got the 2022 data all calculated yet, but I'm not sure that pointer's going to work for me. Oh, I got it. By golly, well, this is pretty hard. No, it's right there. I got it. Anyway, it's 52%. Well, it's on this screen, and it's enough. Anyway, 52% of yield potential is all we got to, on average, which means we could double our yields. And that is a really, really powerful thing. And we calculate that using soil available water, rainfall, solar radiation, and I'll talk more about that because it's one of the things we have done a crappy job on is solar radiation. And it really helps growers look towards what they could do and what the potential is, and always gives them something to reach for. It's really quite cool. So, you know, we're talking about lodging, man. Out of the YEN program, and it's not rocket science, but boy, some of the things that we really have found, nitrogen rate matters. Why does nitrogen rate matter? Because we want high yields, you put on lots of nitrogen. That just is the way that works. One of the things that was a bit surprising to us was heads per square foot. And so so we need more heads per square foot if we're going to get high yields, but there's some real concerns about too many heads per square foot, because then you get lodging. And so it's this balance, right? And then total biomass. Total biomass is not rocket science. For goodness sakes, grain yield is just 1% of total biomass. You want high grain yields, you have to have total biomass. You can change the harvest index a little bit, but not very much. And so you need high biomass. And just as I go through the rest of the presentation, when you see these slides with the YEN show up, it's just going to be showing you what some of the highest yield growers, some of the highest potential yield growers are actually doing from a lodging perspective to support some of the things that we're going to talk about in terms of managing lodging. So I think that's pretty cool. So lodging, right? Lodging is one of those things that has all sorts of crappy things that it does to us. It reduces translocation, it causes root damage. You can either get stem break or you can get root lodging. But we often think that because if you get that reduced translocation from stem break or you pull the roots out of the soil, that's where all the yield loss comes from. A lot of it actually comes from reduced photosynthesis. When those crops lodge, now we get shading. And once we get shading, then we don't get the same utilization of sunlight. And in actual fact, like you think you want more leaf area index, too much leaf area index is a bad thing in cereals because it shades the lower leaves. And so it's one of those things that you want lots of leaf area, but you know, way back when we all thought that big flag leaves, baby, you want a high yield wheat, you want a big flag leaf. The best breeders breed for small flag leaves because small flag leaves allow the sunlight to penetrate to the lower leaves and you get photosynthesis through the whole plant as opposed to just one leaf at the top of the plant. So it's kind of cool from that standpoint. When we get this reduced photosynthesis though, or the reduced translocation, we really do get into these situations where we get purple stems. And what are purple stems an indication of? Come on. Exactly, photosynthate buildup, 100%. And so you can see that in this particular example, we've got lots of purple stems. Where my red circle is, you can actually see a head where the stem broke to the point that it hasn't filled at all. I hope you can see that. If not, you can zoom in on it later if you want to have a look at it. But we get those buildups of photosynthate. We're not turning that into grain. And so we kind of get into that situation where, lodging, a good rule of thumb for lodging is that you, and it can vary for sure, but on average with lodging, you probably lose a bushel per acre per day for every day that crop is lodged between when it lodges and maturity, grain maturity. And that's a pretty significant number when you think when you think about that. So there's some other things as well besides the reduced photosynthesis, increased disease and pest risk. I mean, you don't think about this, but the amount of pest damage in a lodged crop, the mice love wheat. And if the wheat plant is standing up, they can't crawl up to the top and eat it. But I've combined a lot of lodged plots. We do a bunch of research on this stuff. And when you're combining a lodged plot, it's not uncommon to see 500 mice. You know, did you see the mouse outbreak, the mouse epidemic in Australia? Like, it's almost like that. Like, there's just mice everywhere. And that's all cutting into your yield. Reduced combine efficiency, of course. You can get more disease as well. And you get the greatest yield loss when lodging happens at anthesis. And the reason for that is that as soon as you have anthesis, like up until anthesis, what's happening with the photosynthate? It's going to build more plant and it's going to root development. You hit anthesis, and what is the big sink for photosynthate? It's the head. So as soon as you have that sink there, if you've damaged the roots at all, then you don't get the same recovery of the root system because you're sucking all that photosynthate up. And so you get the greatest yield loss at anthesis, and in really bad cases, it's been up to an 80% yield loss. Typically, 10 to 40%, but you can get up to that 80%. So I want to start here with the lodging story. Like, can we predict lodging? Because the easy answer is just manage like the crop is going to lodge all the time. But that is a very expensive way to manage for lodging. And so if we could predict when lodging was going to happen, we'd have a much better indication of when we should apply a growth regulator or some of those other management techniques that maybe we could look at. And so I'll start here. The first one is temperature. And in a wheat crop's life, what is a perfect day in a wheat crop's life? 18-degree temperature in daytime, John. Yep. And nighttime? Yeah, no, it's on the screen, John. Look on the screen. Read the screen. It's a nice try, but it's not. So perfect. Like, it's a cool season crop. I give you the answer. It's an 18-degree day and a 10-degree night. And so one of the things that does hammer plants from a lodging perspective is what? From a temperature perspective, what hammers it? Warm nights. I don't know who said that. You should get a prize. Warm nights. Why? Because if you have a warm night, respiration goes up. And if respiration goes up, you have less photosynthate to build a strong stem. And I've talked about this before in Manitoba or in Saskatchewan, and I got somebody who immediately pushed back and said, yeah, Johnson, you can say that, but I don't worry so much about warm nights. I always get lodging when it's cloudy and rains a lot. Well, it's sort of the same thing, and we'll talk about that in a minute. But if you get nighttime temperatures through stem elongation, right? It's really stem elongation that matters. You get 20-degree nights or hotter, and you will have a lot of lodging potential just because of that nighttime respiration. You get a certain amount of photosynthate, made in the daytime, and if you have a cool night, Like if you get this much photosynthate in the daytime and you have a cool night, you respire some, you have this much left for growth. If you get a warm night, you only have this much left, and so you get a much thinner stem from that standpoint. So certainly warm nights, moisture, 100%. The more moisture you have, the more lodging prone you become. And so it really does come down to kind of, sunlight and where we're going with that. One of the things that I'll throw at you that I think is really cool is that yields are going up, right? Why are yields going up? And everybody wants to say, oh, we've got better varieties. Yeah, we got more agronomy. Yes, John. Are you an agronomist, John? Good, Tammy. Good, yeah. No, like everybody wants to say it's genetics and it's agronomy. In actual fact, about 50% of our yield increases are coming from solar brightening. The sun is now 27% more solar radiation than it used to have 25 years ago. That's research by Thijs Tollenaar. And carbon dioxide. When I was born, we were about 320 parts per million of carbon dioxide. Now we're 415. Wheat is a C3 plant. C3 plants benefit a lot more from high carbon dioxide levels than C4 plants. So your corn and your sugar beets don't care. Your soybeans and your canola and your wheat, they care. And so that is part of where we're getting all that high yield. But it really, it's all about the water. Well, maybe it's all about the water. When it's raining, what else is happening? If you're trying to make photosynthate and it's raining a lot, right, it's cloudy. And if it's cloudy, how much photosynthetically active radiation do you have? And the answer is less. No, don't say not much. Typically, when it's cloudy and raining, you get about 80% of the photosynthetically active radiation that you get on a bright, sunny day. But if you're talking about what's left over, that 20% difference can make a big, big difference in how thick the stem is, how sturdy that stem is. And so sunlight matters. When we're looking at trying to predict lodging, you can look at nighttime temperatures. I think that's one place you can start. You look at moisture for sure, but look at sunlight. If there's one area that we have done a crappy job as agronomists in terms of understanding yield and crop development and how we could manage, we simply have not, like who in here, in this room, actually looks at sunlight data through the growing season to know what the yields or the crop development is like? I got, good for you, Ben. Good for you.
Forest fires.
Forest fires. Yep.
It puts a crimp on things, man.
Yeah, 100%. But it is like that, we don't even look at it, and yet that is the driver, right? And so this is not lodging, but this is the data that I have, and this is actually to do with yield, but you think it makes a difference or not. So we head out in the early June on winter wheat in Ontario, and this is 2015 and 2016, and if you look at 2015 and 2016 in June, that is a 23% increase in solar radiation in June. And you kind of say, well, what difference does that make on yield? Our provincial average yield went up by 23%. And the same thing happens with stem strength and lodging. So you can put those three things together. I think it makes a pretty nice thought process to go through from an environmental standpoint. Topography matters as well. And man, when it comes to topography, if there has ever been an opportunity for site-specific management, it's in wheat and using topography and soil type to predict where lodging is going to happen. And once you do that, with the precision agriculture opportunities we have today, there's all sorts of things, and we'll talk about those, but man, it's really an option, and too many of us are still treating that wheat, all the things we do in that wheat field uniformly across the whole field. And it's just, we can do better. And then the last thing is soil type, right? Soil type, soil type, soil type. Wheat never lodges on heavy clay because it never grows tall enough. It just doesn't. Like you get really heavy clay. Maybe it's different in Manitoba. You got heavy clays with all sorts of organic matter, but man, you come to Ontario, if you have 65% clay soil, wheat doesn't lodge. You can just about do whatever you want. So you can use that in your topography and your soil type, but all of those factors can come together to help you make better lodging recommendations. And I just think that's cool. So, which one of these things is not like the others? Yeah, just a little bit of fun. All right, lodging management. So there's a whole range of things. Where are we going to start? What's number one? Nitrogen. Oh yeah, everybody loves to, man, everybody just loves all the inputs, right? It's all about crop inputs. Nothing else matters. What do you think? Where do you start with lodging management? Where are you going to start? Thank you very much. Genetics, 100%. So I just pulled this out of the Manitoba Seed Guide. It's not rocket science. And actually, I was surprised in your seed guide at how little variability there was for lodging in your wheat varieties. That's actually a good thing because you've done a super job on your genetics. What I found interesting was that when I went to the barley and I look at the barley lodging ratings, they're all lower. So you want to manage lodging in a very lodging-prone field. Not only do you look at variety, but don't grow barley in a lodging-prone field because it just doesn't have the genetics to stand as well. And we don't often think about that because you say, well, I'm going to grow spring wheat or I'm going to grow barley or whatever. But picking species matters as well. And then the other thing that I find really interesting, and talking about crown rust in oats, right? And so when you talked about crown rust in oats, this is oats in Ontario, and we do our performance trials with and without fungicides. And if you look at the bottom there, those are our lodging ratings where we sprayed a fungicide versus where we did not spray a fungicide. And when you get heavy disease pressure and it takes away photosynthetic area from the leaves, what's that going to do to your stem strength? You're going to have less photosynthate. It's the same as having a cloudy day or anything else from that standpoint. So if you have heavy disease pressure, and that's one of the things that happened to us in 2021 in winter wheat in Ontario, we had very heavy powdery mildew pressure early in the year. And normally I don't even worry about powdery mildew pressure because we get over 28 degrees, powdery mildew stops, we always get hot, we don't worry about it. Man, did we have lodging where we did not do disease control. It can have, doesn't always, but can have a significant impact on the lodging that crop will have. So if you don't, by the way, I'm not a proponent of early fungicides. Most of the time they don't pay. If you're automatically putting a fungicide on at your herbicide timing on your wheat crop, I would say that 9 years out of 10 you're wasting your money. You get a bushel and a half, and it costs you 2 bushels for the fungicide. I save those fungicide dollars for later. But on those years where you get early disease, you need to control that early disease because it does have, and we've seen that, an impact on lodging. All right, so we've got genetics, we've got disease control. What's next? Well, clearly none of you have read the wonderful synopsis that I put in the proceedings.
It's like 4 pages long.
It is not 4 pages. I do not write 4 pages. Anyway, yeah. So here's the next one. And, you know, this is some data from Amy Delacouille now, Amy Mangeon. Do I say that right, Don? How do you say it? Manger, pardon me. To me, it looks like Mangin, okay? But Manger, okay, Amy Manger. But, you know, we come back to this whole thought process about where do we start with lodging management? And everybody wants to start with, oh, we'll just do it with nitrogen, or better yet, the easy answer is we're just going to sell everybody plant growth regulators. Well, man, there's so many other ways that you can actually start managing your lodging risk. Now, who in the room is willing to reduce their seeding rate to reduce the lodging potential? Nobody's going to do it, right? Why not? Why is it too risky? Anything could happen in the spring. So, what I'd like you to think about is where you get lodging, what are the growth conditions that seed is exposed to? Like you get lodging in the best areas of the field. Do you tend to get very much or higher mortality in the best areas of the field, the higher organic matter areas, the better drained areas? So you're right, anything could happen, but where you have the highest risk for lodging, you have the lowest risk for having a problem with that seed. You have the highest potential for getting good tiller numbers from that seed. And so when you look across all the seeding rate data, the one reason that you guys don't want to go to a lower seeding rate is because of this days tan thesis. And I don't know, I don't think when I use the mouse that it shows up. It may show up for the virtual people, but it doesn't show up on the screen. Regardless, if you look at the days tan thesis column, once you go to a lower seeding rate, you get more tillers. Once you get more tillers, you have a more variable stand, and everybody in the room is nodding their head saying, oh yeah, we ain't doing that because number one, it's harder to time the fusarium spray, and it's going to slow down my harvest date. It's going to delay my harvest date because it's not uniform. Well, okay. But again, if you're doing it in the best parts of the field, typically you're not going to see as much of that problem. And one of the things about reduced seeding rate is that reduced seeding rate reduces lodging risk. 100% reduces lodging risk. And we have not utilized that technology, and I want to come back to the seeding rate zones. I think there's real opportunity in the work that we're doing right now in Ontario. The number one return to investment from precision agriculture is with wheat seeding rates. And we can pull them back in the better areas of the field, and we don't lose yield. And I'll show you that in a minute. But if I look at seeding date in Ontario, and I know there's not many winter wheat people here, but when we look at seeding date on winter wheat, as soon as we seed later on winter wheat, so these are 3 seeding dates. This is actually Kurt Steinke's work out of Michigan State University. And what happens? As I reduce my seeding rate in winter wheat, well, guess what? The later I seed winter wheat, the shorter the crop. And so if you are a winter wheat grower and you seed early and you don't reduce your seeding rate, you will get lodging, 100%. But if you seed early, you pull that seeding rate back and you actually get higher yields. So plant height, this has always amazed me. In the data, because I looked in spring wheat data, I couldn't find much difference between seeding date and height of the crop in Manitoba, or in Western Canada for that matter. And so it may not be a spring wheat thing, but in a winter wheat, man, it makes a huge difference when you seed that crop, the height of that crop, and whether or not you get lodging. And you can manage all of that with seeding rate. We've proven that in Ontario. We pull back our seeding rates. So it really is a seeding rate by seeding date thing. And just to prove it, we'll go back to the yen. This is the 2022 winner, Jeff Crone out of Michigan State. By the way, our Great Lakes yen is Michigan, Ohio, Wisconsin, Kentucky. It's kind of funny. I didn't know Kentucky was a Great Lakes state. You guys probably don't even know where Kentucky is. But anyway, but what's really interesting here is that Jeff is seeding early, not super early, but early on September 17th at 0.8 million seeds per acre, which is 50% of the normal seeding rate. And he won not only the yield competition, he also has the highest percent of yield potential with 50% seeding rate. So this seeding rate, I just think, is one of those things that we overlook. So you want yield, you want protein, it takes nitrogen. As soon as you have nitrogen, man, you get increased lodging. The higher the nitrogen rate, the more lodging you get. This is Sherry Stridehorst's work. She's not worth Alberta agriculture anymore. It's too bad. But, you know, realistically, it just, this is not rocket science, but it is one of those kind of situations where it's a push-pull. I want more nitrogen to support more yield. I put more nitrogen on, and I end up with more lodging. So we need to, and this particular trial, you can see manipulator was applied, so the PGR was applied. And I come back to Amy's work, because I think this is really cool stuff that she's doing, just, you know, looking at different nitrogen rates. So the standard rate there was 140 pounds per acre, and you can see the difference in the genetics, but you can also see that the reduced rate had quite a bit less lodging. I find it pretty interesting, and so tell me why did Brandon lodge more with ESN? So the blend was 28% urea and 72% ESN. Why did I get more lodging with the ESN? Because it, yeah, so the comment, it hadn't broken down until we hit basically stem elongation. You want to maximize your lodging potential. You just about growth stage 30, right when we go into stem elongation, you just power a whack of nitrogen there. I think what happened with the ESN, and I don't know this for sure, it wasn't in Amy's, she didn't really address the why of this in particular, but most likely the urea, a little bit wet spring, maybe we got a little bit of denitrification or a little bit of loss, so with that straight urea, we had less total nitrogen there, and the ESN just released about growth stage 30 and a big whack of nitrogen, and we actually got more lodging. I'm not sure that's the case, but it sure looks pretty suspicious to me. And so then what Amy has done, and this is really cool work with they call it the stalker, and it measures the stem strength of the wheat plant. And when you look at the stem strength, remember, we did talk that anthesis is where it matters the most, and this is measured in newtons. I guess I didn't put that on there, sorry. This is measured in newtons, but you can see clearly that at anthesis, and interestingly enough, at anthesis, the reduced rate actually was the most lodging prone. So it must have been just not having enough nitrogen to actually get to, the least lodging prone. The least lodging prone. The higher number is better. So the least lodging prone, and so that makes a little bit of sense from that perspective. Okay, going to keep going. And then you look at split nitrogen, and split nitrogen, whether it's Amy's work or Sherry's work or our work out of Ontario, as soon as you split your nitrogen, you end up with, it's a win all the way around. What's amazing is when I look at the data, nobody wants to split nitrogen. Why not? Why don't you want to split nitrogen? It might not rain when you want it to. You know, and I know that's a risk. And when I spoke in Montana, they're in the third year of severe drought. Montana hasn't rained yet. Okay, I give you there. But like when you look across Western Canada, that risk of it not raining and ending up with lower yields is probably 1 year in 10. It's not as high a risk as everybody's brain tells them that it is, and most of the time you take no less yield. And in this particular study, no less yield and much, much higher stem strength. So you can see the split is at 3 newtons versus 2.66. The other really interesting thing that is in that study is leaf area index. And as soon as you put all the nitrogen on up front, you get all sorts of vegetative growth. You get a higher leaf area index. You would think that should be a good thing, but what happens is you get shading of those lower leaves. and you actually make yourself more lodging prone by having very high leaf area indexes. And that's work done by Pete Berry out of the UK. That's kind of cool stuff as well. So split nitrogen is just almost a no-brainer in my mind. This again is Sherry Stridehorst's work, and she actually went up to 3 applications. And when she did that 3 applications, no yield reduction whatsoever, and she got much less lodging, and that's Alberta, right? So this concept of stranding nitrogen is real. It can happen, but if you want to manage lodging, boy, it's one of the best ways to manage lodging. It's also, by the way, Mario, one of the best ways to reduce nitrous oxide emissions, right? Split nitrogen. Yeah, so it's a win-win from that standpoint. Okay, and so just to show you again, come back to the yen. Everybody in the yen that wins, everybody, to a person, splits nitrogen, right? They just do. Sorry, that's bad. That circle got moved a little bit. I apologize. You can't even see what it says, but it does say split nitrogen. Wonder if I can back up. Well, anyway, you can look at it later. What can I say? All right, so now let's get to what you really came to hear about, is that's plants growth regulators, and plant growth regulators work, okay? They work. There's no question that they work. They definitely, they work, but they have some issues. And the issues nobody wants to talk about. And so I'm going to be John Hurd. I'm going to tell you about the issues as well. So this is actually in Germany and the UK. And by the way, if I just go back, like, plant growth regulators are the easy answer. When we got Roundup resistant canola, what was the easy answer? Roundup by itself, right? You had more weeds, what did you do? Spray more Roundup, 100%. And how did that work out for you? Not well, thank you. So in the UK, right now, the malt houses that buy the barley to make that cursed, rotten Guinness beer that I don't understand how anybody can drink, they will not buy barley that has had a growth regulator applied to it, period. Which is ridiculous, because there's no way that even if there was residual in the barley crop, the chances of it getting into the alcohol is 0. But the average wheat crop in the UK gets 1.5 applications of a plant growth regulator, and they are finding plant growth regulator in the bread. Now it's it's way below the MRL, the maximum residue limit. So who cares? It's not a health issue. But everybody in the room, as soon as I said that, you all kind of groaned, right? Because the perception is 10,000% bad. So, growth regulators in the UK and Germany, this is some German research or a German researcher, and they use it for way more things than we do, because it will even out tillers. They really try to make it or utilize it to its full potential. But they're putting, look at that. The first application they put on when the first white roots are 1 inch long, and you just go, wow, that is like 2 to 3 applications. They're really pushing it to do a lot of things. We're never going to go to that point. But what they're trying to do is they're trying to make that perfectly uniform crop. Because when you apply that growth regulator, it actually removes the apical dominance for a short period of time and lets those late tillers that you were worried about because you had a low seeding rate catch up. And it will even out. And if that's a crop that we all look at wheat, and if you actually look at wheat and you walk it very much, there's all those late tillers down in the canopy, and they're the ones that hold up harvest, and they're the pain in the neck. By the way, they still do add yield, but they're trying to get totally away from that. And they do that using growth regulators. One of the other cool things about growth regulators is that you actually get more root growth. And so again, Amy has some research that supports more root growth. You're in a dry climate, more root growth is really important. And so you would say, well, all the time I should get a yield boost. Well, the other thing that plant growth regulators will do is they affect stomatal closure. And so if you have marginal drought with a bigger root system and the stomates stay open a little bit longer, you can get a yield increase. But if you're under severe drought and the stomates stay open a little bit longer, guess what? You get a yield reduction. And so there's, like, growth regulators are really cool, and they're new to us. They're not new. They've been using them in Europe, I think, since the 70s. But at the end of the day, do they work? And the answer is yeah. As soon as you apply a growth regulator, you're going to get less lodging. You know, one of the other things, and this is Amy's work, I maybe should have thrown in my work here, you can see less lodging. You can see a hair more yield. It's pretty minimal, and mostly in the absence of lodging, the yield increase is generally very small. A bushel, 2 bushels. In our work in Ontario, it was about 2 bushels that we got most of the time. But that's okay. You get shorter plants, like lots of things, but they do, in general terms, they delay maturity. So in our work, we would say they delay maturity at least 2 days and often 3 days. In this work by Amy, it was just, you know, it was statistically significant, but it was not very much in terms of actual total delay in maturity. But be aware, they definitely do that. And then, you know, you look at different species. So we're using growth regulators on oats. We're using them on barley. They work. I think I'll skip this because I'm going to run out of time. But we get, so this again is Sherry Stridehorst's work. And I find this really interesting because she's got manipulator, was chlormaclot chloride. It's the long-serving one, Cycocel, whatever. And now trinaxapac ethyl, which is Modus. And I didn't even talk about ethyl. Ethyl works, but it's really got high potential for phytotoxicity and reducing yield. But what I find interesting in Sherry's work, and we support it, is that you can see here the manipulator worked really well on Brandon. The trinaxapac, the Modus, did not work as well. If you move to the next one, then Wheatland, both manipulator and trinaxapac work equally as well. And when you look at across a whole bunch of varieties, then the data at the bottom is sort of her findings. If you have Wheatland, they both work, but it's such good genetics, you don't need them. So you start with really good genetics, and you just don't need them. If you look at a variety like, Landmark, then anything works. But if you get into Viewfield, only manipulator worked, and the Modus didn't. So I want to take that one step farther, and I'm going to run out of time, so I got to do this quickly. But this is Ontario work. And 2020, C&M Seeds did a great trial with split application of nitrogen, single application of nitrogen. And I'm just going to run you through 3 different varieties. So here's Wilkin. Wilkin has tremendous standability, tremendous, like hardly ever lodges. What do you notice about applying manipulator on Wilkin? Those are yield indexes. What do you notice? Significant yield reduction. Not just a little bit, a whole lot. You move to the next variety, Easton, and it's average for standability. What do you notice? When we put a single application of 120 pounds on, we lose yield. When we put a split application, but we up the nitrogen rate to 155 pounds, it's looking like maybe there's a yield boost there. Isn't that interesting? So I'll leave you to ponder that one, because that's just interesting. And then you get to this one, this Raven, and man, if you don't put a growth regulator on Raven, you give up a ton of yield. So all of our growers actually, or I shouldn't say all, a lot of our growers in the Yen definitely do use plant growth regulators. It's one of the tools they use. In fact, when you look across all of it, 65% of farms used it. And with that, that's kind of the wrap up, because there's a whole bunch of things that I think you can do. I caution you, in Ontario, on winter wheat, on soft red winters, we can almost use growth regulators and they seem okay. If I move to hard red winter wheats in Ontario, we have taken, under adverse weather conditions, so nighttime temperatures that went down to 0, we took a variety that was 48 inches tall and we made it 18 inches tall. You can, like, just be careful until you learn how plant growth regulators work. And with that, I'll shut up. Thank you very much.
I just want to see if, do we have any questions online?
The only comment there was from David Rourke, who said that it's not always too dry here for split N applications. Sometimes it won't shut off the rain so that we can put that split application on too. So, and I'm sure in Ontario you never have that happen. And then Zoom kicked me out, so I can no longer answer anything.
All right, and what about from the audience? Do we have any comments from the audience here today? Oh, there's one.
I learned something today about solar radiation. You said it was increasing since, say, 30, 40 years ago. What's the reason for that?
So I think part of that is probably the whole global warming aspect, where we have a little bit thinner ozone layer and we're letting more of that sunlight through. I'm not sure that I can tell you all the reasons, because I'm not a climate scientist. If you want the paper, it's Dr. Thijs Tollenaar. He was the crop physiologist at the University of Guelph. He went to University of California. That's where he did that work. But if you look across most of North America, our sunlight has definitely increased over that time frame. The photosynthetically active radiation has increased, and it's part of the reason why we get higher yields.
What about potassium? When does potassium kick in? Is that, and what kind of critical levels do you talk about with your growers?
So on what crop, John?
Let me say, spring wheat. Tell us what we want to hear here. Spring wheat, potassium.
So spring wheat, potassium, I don't know. In our data set, wheat is not responsive to potassium. In early growth stages, there are 3 things that the wheat crop needs. It's called phosphorus, phosphorus, and phosphorus. And potash, it's interesting because barley needs potash, corn needs potash. Man, if you are low potash and you don't put potash in the starter on corn, you throw all your money away on the phosphorus you put on wheat, the phosphorus you put in that starter band. Because without potash, without that balance, corn falls apart. But on wheat, John, and besides which, you guys have such high potash levels. What are you even asking me the question for crying out loud? Like, it just doesn't matter. Cool.
Thanks, Pete. Up here, great presentation as always. Thinking about your split application on for nitrogen. Tried to do this before with corn and using polymer-coated urea, and I don't know if Mario might want to jump in on this one too. Is there a way for us to actually, and given the importance of putting that nitrogen on that second application and having that timing so critical, is there a way for us to use a polymer, but like a real slow release product, to get the actual split application effect we want, or do we need to travel through again and dump another shot on?
So it's a great question. In our work, split nitrogen outperforms ESN or a polycoated urea all the time. And the problem with the polycoated urea is that it's time and moisture. And when is the rainfall going to come? When is the temperature high enough? And so with corn, we've been able to make polycoated urea work because corn has a longer growing season, and if it's a little delayed in its release, that's okay. Sometimes with ESN on Ontario conditions, it dumps almost like urea because we put it on first week of May, and we get a really warm, damp May, and it hardly slows it down at all. and then we don't see the benefit from a split application. On wheat, on our wheat crop, our demand is so early that we have had, ESN has not worked. Polycoated urea has not worked on our wheat crop at all, and I think you'll struggle with it here as well, just because of your timing of demand and the fact that you don't know when it's going to release. But I don't know. I haven't seen I haven't done that research, and you'd have to look at Amy's work a little bit closer to know for sure.